Welcome to wasmCloud Machine Learning Thursday, I guess. We're going to start today. Steve has a proposal on iterating the API. Steve, would you mind sharing your screen and maybe giving us a walkthrough about what your proposal is all about, what it is that you'd like to solve for?
Yeah. Um, Alrighty, just a sec here. Fuck.
I
Oh,
just
there we
gave it
go.
to you. Sorry.
Got it. Okay. Okay. This is in a Google Doc that I just shared on it's also shared on the chat for the Zoom call. Um, so it's a proposal for a small change to the wasmCloud proposal. And the specifically what it does is it adds a couple of tag bytes to describe the kind of data being sent in a tensor. The current structure is defined there in the current wasmCloud spec, and the data is always an array of bytes. And this is sort of pseudocode. It's sort of Rust-like, but not exactly Rust-like. But it's an array of bytes, and the idea is that the sender and receiver have previously agreed on what that means. So, for example, if it's a 3 by 3 by 3 array of F32s in row major order, then every 4 bytes of that array is to be interpreted as an F32. There's also an implicit understanding between sender and receiver about whether it's little endian or big endian. And then if it's row major order, anyway, you can unpack it in that form. There are when I first saw this, one of the things I was worried about is just all the implicit information that is assumed for the sender and receiver to coordinate the data. Also, it requires the sender to be able to format the data in the right format. And if it's a low-powered edge device with constrained memory, it might not be easy to reformat or repack the data in a different way. And so what this proposal does is it adds just a couple fields that describe how that data is packed. So the data is still sent as an array of bytes, although there's a potential way to expand this proposal where if it's not stored that way in the sender, it could become an array of arrays, but I didn't include that in this proposal. So I raise a couple of, in this document, I bring up a couple of reasons why it could be error prone. And Andrew brought up that WebAssembly has standardized on little endian or bit ordering, which could, for messages that go in and out of WebAssembly, the fact that if it's known to be little endian, then that reduces the variability somewhat. But there are some realistic scenarios where the WebAssembly is just an intermediate node, and it might be receiving data from somewhere else, and the WebAssembly is the last hop before being sent to the provider. So, so the proposed change is to add a flags field, and for types, instead of there being just one type, for the types to be an array. The flag field has 2 bits defined. One is whether it's row major or column major order. The other is where it's little endian or big endian. And then the types field, I might have gone a little overboard in turning types into a bit field, but basically the idea is that each the types array has one value for each dimension of the tensor. And so, for example, if you had 3 dimensions of F32 and 1 dimension of U8, then you could have a 4 bytes in that array, where 3 of them would be hex 82 and 1 of them would be hex 0. And that was it. I did also mention that one of the things that inspired this was spending some time looking at CBOR serialization, and there's an RFC for how CBOR does serialization of typed arrays. And they have some specific tags. I considered, instead of defining these values, I considered using the same tag values that were in the CBOR standard, but I didn't want to tie the two things together, since this is an API proposal and that's a serialization proposal. So happy to hear feedback on this. I have a couple other thoughts on ways I might modify this, but I'd love to hear. I know there's people on the call have thoughts on this.
Yeah, I can jump in first. So Steve, I would say this is great work. I especially like this array type. That definitely is needed. I will even go down. You found a bug in original API definition. Definitely required feature for like a non-vision CNN type of machine learning model. So I think we would need to modify the WADI and then at the future point to accommodate this change. That is, this type need to be a multi-value array type rather than a single value. So as opposed to that, the other thing you are proposing, the big little ending proposal, I'm a little bit concerned about this. I think when you are doing machine learning, right, you basically need to do two stages of work. So the first stage is data preparation. You do all kind of things like little ending to big ending, translation, data normalization, and multiple ways of data normalization, right? Your image might be encoded different ways. So basically, whenever somebody is training a machine learning model, by default, they pick a specific format on data representation or how you normalize the data, right? And anybody that try to use this model for inference will have to adhere to this, specific format. So that's basically the task of the data preparation. So it's really a complicated issue. It's more than, big little ending translation. So I'm a little bit concerned that we are combining like 2 different problem domains into a single one and consolidate them into a single API, because you're only catching like a part of the data preparation in this API. So I think, a more modular approach will be something like have a separate API to do data preparation, for the case that your edge device may not have processing power to do the, job adequately, right? So you might need to have a server support and having an API for data preparation. So it's not limited to like the translation between big and a little ending. It might be, image encoding, decoding, normalization, renormalization, whatever you need to do to, make the data format like comply with what the original assumption of a machine learning trainer, right? So that's my input.
Yeah, I understand that. That's a great point. My thinking was that for something like image preparation, yeah, there's certain other features, like you might expect the image to be compressed to a certain fixed width and height, for example, or cropped in a certain way, or using a certain color space. And if you were making an API that transferred images, you might want to include those things as part of the API, like the dimensions of the image. Since this API is not specifying any kind of higher level objects, it's specifying just numbers. I thought it might make sense to describe the format of the numbers that it's sending. I don't think that this imposes, at least the way I was thinking about it, I don't think it imposes a burden on the sender to do the data preparation. So there's still kind of an implicit part of the API that requires the sender and receiver to agree on who's doing the data preparation. If the sender, say an edge device, is not able to convert little endian to big endian, then it will have at least sent in this API with the extra flag bits, it will have sent the description of the data so that the receiver could do that last bit of data prep. So in that case, it imposes a reformatting burden on the inference engine, which is a separate concern from the data formatting. I think that's what you're saying. So
and in addition to that, the server implementation doesn't have any knowledge of how the data is formatted. That is that you could load different models, right? So you could load a big ending model, or you could load a little ending model next time, and basically knowledge is embedded in the model description, right? Usually.
I would think that would be an even more important reason to have the input tensor to be tagged with whether it's little endian or big endian, so that if the server does change models, then the server can reformat the bytes, the input bytes, if necessary.
Yeah, that's of course that's one way of handling it. In my point that this is just a small aspect of a data preparation problem, which is like a very big problem. So yeah, I'm actually curious. Do you have any specific use case for big ending? Do you deal with big ending device for a particular problem?
I don't right now, except that I have seen some serialization. As it turns out that CBOR has standardized on big endian, but no, it was just a conceptual omission from the way I was looking at it.
I see. Yeah, we actually look into expanding wasmCloud for ease of use purpose. Exactly what you characterize here. For example, we thought about setting up some helper library, to send a JPEG image, and it convert to appropriate tensor format. So we that's kind of approach we thought about it. So there could be an SDK library to help this, to make it easier to use. And in the end, we say that it's probably not mature enough to incorporate into the API specification. So, but you can still put it in the SDK, for a ease of use purpose. That's another way out. Basically to have supporting utility functions that that people can use, but not in the API definition.
Right.
Hey, Steve, I mentioned this earlier up in the thread, and I'm interested to hear what you think about this now. So the proposal you suggested, does implicitly require the receiver of the tensor to be able to transform the data. And so it would make all WASI-NN implementations bigger, right? They'd have to handle the translation of data. If, like Mingshu, we wanted to do that in a separate, through some separate mechanism, I don't know, maybe a separate provider in, or separate actor in wasmCloud or whatever, right? It seems to me that the level of metadata that you're trying to add here would be important for such a translation function. And I mentioned previously, what if we added a way to the WASI-NN APIs to introspect the models, and so that you could say, well, I have a model, I've instantiated or whatever. I want to know, okay, for input 0, is it big little endian? Is it row major, column major? Is it, etc., right? What do you think of that track?
And are you saying that we would not make the flags and the types explicit, but that you would provide those functions, and then you'd have a different way of sending those, or that I don't see how you could do it without sending that type data.
Well,
no, actually, yeah, let me interrupt. So I think the idea has its merit. That is that if you provide a data transformation actor, right, and it serves
Yep.
that purpose of do all kind of a data transformation,
Mhm.
big little ending, different image encoding format, and even for a normalization. Yeah, do you want to normalize to -1 to +1, or do you want to normalize to 0 to 1, right? So those are a very two common scheme that the people use for machine learning, and they may use different schemes. So you need to do, appropriate translation of the raw data. So maybe that's a valid, a very valuable service that somebody could provide as the capability provider.
Yeah, I see. In fact, we could provide a library for either side, either in WASM or on the servers for a server side, that does these arbitrary translations. So that could take the spec of the current input tensor and then the desired format that needs to go into the predict engine and do the right transformation. And absolutely, that could be a library so that every WASI-NN implementer wouldn't have to implement it.
Yeah.
So yeah, I think that would be a good idea to have. I don't think it. I don't think that eliminates the need to have this data somehow sent along, because that transformation library still needs to know what kind of transformation to do.
Can I comment on that real quick? Yeah. So I think we're sort of mixing two ideas here. The tensor has a shape. Okay, the shape is an array of dimensions. You've identified something that was missing in the shape of the tensor, which is that each one of those dimensions could have a separate type. All right, so that actually is pretty critical to the high level view of a tensor. Tensor actually doesn't understand in this API what its format is. It's just a bag of bytes. So all that the tensor really knows is those dimensions. And I think, number one, I think we should add the types to the dimension, like you suggested here. But when it comes to the actual, serialization of the bytes, we've talked about colors, you know, and color schemes and yeah, even big little endian and stuff like that. I think that is this type of stuff that might not need to live on the tensor object. Because it's a separate concern, it could be you know, handled either separate in a library or by these other WASM functions or whatever. Like, does that make sense? The distinction I'm trying to make.
Yes, it does. And when you say color, you're referring to images?
Yeah. Yep.
Yeah. So but to me, the reason why little endian and big endian are separate from color is because this isn't an image API. It's just it's an image for sending integers.
Yeah,
and
I think
floats.
you know what Andrew tried to say, that the people doing CNN, like they may say, oh, can you add the metadata to specify the image encoding scheme,
Right.
right?
Right.
And the people say, oh, well, I do normalization differently. You know, you need to you know, off the by 0.5 so that I can, you know, be like from -1 to +1 or something like that. So that's
Yeah.
like a floodgate of those parameters that people were asking to be added in the API.
Yeah, I understand. So you think little endian and big endian steps just a little bit into that floodgate, and that we just shouldn't go there at all.
Right.
Yeah.
I mean,
yeah.
I would say the little endian, big endian. That debate. This is a WebAssembly API, so it's all really going to be little endian. Okay, but so I won't even. That flag I'm sort of like shrug, but the other flag, the row major, column major, that I would consider adding, but because it opens the door for all these other, yeah, hey, I want to do RGB. No, I want to do BGR. No, I want to normalize this way. No, you know, that's actually a big problem I think in OpenVINO right now. There's like a ton of combinations of flags, and I was sort of hoping we could avoid that.
Yeah, people say like, you know, you spend like 70% of time to do data preparation, and then, you know, 30% to do the actual inferencing. That's actually pretty accurate. You know, the data transformation is a big problem to me, and with all its complexity. So, so I think that's kind of a concern that we might be opening up the big floodgate here.
Okay.
Great. Well, Christoph just joined, and Christoph, my apologies. Parts of the United States have a time change, and I think our meeting moved up an hour on your time. So our apologies on that. That it wasn't that wasn't clear. So do we want to maybe catch Christoph up on the discussion so far, and what the sort of how you guys are thinking about the this particular recommendation?
Sure. Or did you want to
go ahead, Steve? No, you do it. You do.
Oh, okay. So I know Christoph has read this. Feedback from Minkyu and Andrew was that there are a lot of properties of the tensor that are really specific to the model, and that a lot of those maybe are better to go into the domain of data preparation. And so that includes things about images, like dimensions and color space, and might even include whether the data is centered around 0 or not. And that little endian and big endian probably falls into that bucket. And that they had already received a bunch of suggestions for modifying the WASM proposal to add other features, like is the color space, RGB or BGR, et cetera. And that by adding little endian, big endian, it sort of begins going down that path, and is probably way out of scope to incorporate all the considerations for all the different kind of models. And so it's probably better to not go down that path. Also because WebAssembly is standardized on little endian. And then the second part, so there was sound like a lot of positive feedback on having value types, especially for non-CNN kind of models where the dimensions of the array are not the same type. And so there was favorable feedback on that, and then kind of mildly favor it on row major and column major bits.
Yeah, this is a value type is a great contribution to WasmCloud.
One of the things that so thank you for that. I'm glad. One of the things that I stumbled into a little bit after writing this was the realization it probably makes sense to add a value type Boolean and a value type string, which would be easy to add to this schema here.
Mm-hmm.
So that would be one slight change I might propose to this proposal.
Right.
Strings
Yeah.
can be variable size though, and I'm not sure.
It'd have to be we'd have to standardize on, say, UTF-8. Well, I don't know. I
No,
would
but
assume
I mean, even the number of characters in the string could be variable size. So
yeah.
if you create a tensor of strings, you have to have some way of encoding the length of each string in the value type. Does that make sense?
Yes. Yep. Absolutely.
Okay. Hey, so can I just, what I'd like to understand, you mentioned, I think pandas or NumPy or one of these things earlier, Steve, in the chat window. And I was wanting to understand, what use case, like how do you plan to use these changes? Because I think we want to make it super easy to use, right? I think, but I wanted to understand a little bit more where that's coming from, because there may be other ways to solve the problem, right? And so could you discuss that a little bit, like where, what code, what language, what applications are we looking at?
Sure. So for, and some of the examples I've looked at in both Python and Rust, they use the something equivalent to ND array, and that has something called array base, is kind of the internal data structure that it uses to store arrays. And there's a bunch of different ways that it can store it, but it's an array of multiple dimensions and various data types. The tracked Onyx library uses that internally. So that seems to be a common thread, that the concept of ND array, and because it's available in Rust and Python, I see. So for example, if you take the ImageNet examples, take the JPEG image, use an image library to squish it down to the right dimensions, and create the tensor. So I want to make it really easy for these source language that's collecting the data and invoking this API to be able to take an ND array where the data probably is and convert it into a tensor. And then for the receiver to get the tensor from this API and pull it almost immediately or with trivial transformation into whatever that ML library needs.
Cool. I think we're completely on the same page there. Yeah, ND array was one of the, like, yeah, if we could do 0 copies from ND array to tensors,
yes,
I would be very happy.
Yes, right? We're thinking on the same lines.
Yeah. So, is there a way we can sort of test this out, right? Because is there? Does anyone have any ND array using code out there that we could test out, like how much transformation is necessary?
Well, at least my approach for that is to start with some of the examples, and I know there's the Intel examples repo on GitHub. There's also a ton of TensorFlow examples on GitHub that, so I was going to take some of those, and part of the design of the library would be to really play around with that to try to get to zero copy.
Yeah, hey, maybe we shouldn't dig too deep right now, but let's continue discussing this because I'm all about this.
Awesome. And yeah,
right,
great.
Well, and I want to make sure we give Christoph
Yeah.
time. I know, Christoph, you have been putting in yeoman's work in getting the wasmCloud ML framework going. Are we? Do you think you're ready to hop on and do a little demo, or let us know where you are? Do you want to talk through it if you're in the middle of merging code or something, or just?
Can you hear me? Do you hear me?
Yeah, I can barely hear you.
Yeah, I was merging code late last night from Steve, so I see it has a flaw. Maybe I can switch. Give me 5 minutes, maybe.
Okay. Great. So, Steve, do you maybe want to talk a little bit more about the examples, or maybe Andrew, if we could hear from you, you and Ming-Chu, what would be your ideal example? Because we've kind of talked back and forth about what we're going to demo on the Intel side, and I would love to get aligned on that and understand, is there a particular model you want to see running?
We're talking now. We're not talking now about this good proposal. We're talking about the demo. Okay.
Yeah.
Well, I think there's two things that I would say, and maybe make sure you have more. But I think that the key piece in the demo is the ability to move the inference from the edge to the cloud, quote, right, based on some machine criteria. So I don't know if you guys have that built out in wasmCloud yet, the ability to query like what machine am I running on, and then the ability to move the compute. I am fully confident that's possible, but because you guys have assured me that. But that's one key piece of this, is the ability to move the code. And then the other piece is, I think, Christoph's doing good work with the Onyx stuff, but it might be more interesting for us to use a highly optimized inference engine like TensorFlow for the inference engine.
Yeah.
And I think those two pieces would be
that would be what you would want to see in yours.
Yeah. So I would add a little bit, addition. I think the movement of workload, it should be flexible enough. So some cases you might be like moving a workload from cloud to your edge. So in this case, edge could be your home computer, for example, right?
Yeah.
So as long as I think Andrew basically defines this generic cloud quote unquote, so that's kind of a capability that we'll be very interested in.
So here's one thing that wasmCloud can do today is that if you've got a, let's say your edge device has the image, and maybe that edge device is a cell phone or some Coral board or something. If you have a laptop on your LAN running the inference engine, then it would route to that. And if that laptop on the LAN went away, it would route to a cloud engine. And then if the laptop reappeared on the network, it would route the workload to the local LAN. So it's prioritizing network without specific knowledge about whether there are GPUs or the CPU capability or memory. But that's one kind of thing we can do today. We think we can do some other kinds of routing based on other characteristics, but is what I described significant enough you'd want to see that in a demo?
Yeah. So I think from like a user perspective, they get the benefit of maybe if you connect to the cloud service, you have to pay for it. And if you have a service running on your local PC, then it's free, right? So that's a user benefit. So another aspect is that you might be running your image motion detection on your camera, which is it's a low resolution, so has a lot of false alarm, and you could migrate to a more powerful full-blown machine image recognition server on your local network. So in that case, you have better prediction. So those are like two
Okay.
aspects of a potential end customer benefit.
Okay, I think we have enough detail that Steve and I can run with a story and come up with a story to tell. And what we're going to do is we're going to check this into the wasmCloud demos, into the examples repo as a starting spot. But it should demonstrate, I think we can demonstrate, we got a couple ideas. I thought a cool blog post would be exactly what you just described, Ming-Shu, would be building Nest on a budget. And it could start with a lo-fi model that just pulls out faces and then just sends the face pictures up to a more powerful server that does something else, right? Because you get all the distributed network for free with wasmCloud, and that would be pretty simple, air quotes. We've been working on this project for 3 years, but it's easy now that all the other stuff works. And of course, that Christoph and everybody have been working on the machine learning part. But other than all that hard work, easy. But Christoph, I think you're ready to do your demo if we want to transition over to you.
Yeah, sure, we can.
Oh, super. Great. All right. Let me give you sharing. Just a moment, please. You got it.
Okay, you should be able to see something, right? Can you
Yes,
see
we
it?
see it.
Yeah.
We see your screen.
So that is the current repository. Yeah, it's a complete example. So if you want to replay it, there's also some documentation how to build, what you have to take care of, and it's just a bit outdated. We changed the scripts which start the application a bit, but I will update it tomorrow, so no problem. And you control it via that deploy directory, and any variable you would have to change is hopefully in the env's environment. That should be it. Yeah, let's just watch it. So we have currently no high flying model. It's just an identity input output. So it spits the same, or it gives you the same response what you give back, but it shows the whole thing. I mean, let's just start it and then let's have a look on that. So I'm now in the deploy directory, and you can, if you do not know what controls you have, just launch the run script without any argument, and you should start the bindle server first, and there are also scripts preloading that server with a bindle. That's necessary, of course, because that capability provider will fetch it. So we'll fetch at least one. And I have started it already. So the application started with all. What do we have? We have a nuts running in a container. We have a registry that wasmCloud host runs as well, of course, not in a container though. Bindle server also was started before, not running in a container, but starts up. Below, I'm in the folder where the logs reside of that wasmCloud host. Let's see what's inside. Should be an Erlang. And from time to time, I look what's in there so I can see if it starts up properly. And so it takes a while. Meanwhile, we should see the washboard coming up. Let's reload the page. You're probably aware of that board. On the top left, you see the inference API already, that actor. On the top right, you see the capability provider. Both of them are already up and running. What's missing is the HTTP server. It takes a while, a bit longer. On the lower left side, you see the two links. So we've got one link from HTTP server to inference RP actor, and that is the lower link. So the contract ID is wasmCloud HTTP server. The upper link connects the inference API, so the same actor, but with the other provider, with a wasmCloud example ML inference capability provider. So now we see all the technical stakeholders up and running. We switch back maybe to to make sure everything works fine. Usually I print out the logs. You can play with it, but looks fine. And then yeah, you can launch requests via curl. We can have a look maybe at that command. Let me copy it out here, make it a bit bigger to see what we do. So that's a post. It's going to that port which was configured somewhere in the scripts of that HTTP server, and then we want to have a query against the model called Challenger, and then we've got a different parameter. It's isIndex. All the other parameters come with the metadata and will be loaded from Bindle server itself. What you see below, that's in the body, and that's yeah, that's some data. Okay, and well, now we can launch it. So the data, you want to have the prediction upon or against. That curve was started with -v, so this is for verbose, and it's always important to get back at 200, which we do here. And then you see that result. Maybe it's a bit verbose, but it's not bad for the beginning. What's important, has error false. And then you see the output tensor. If you look very closely, you see that the output is indeed identical to the input. We can make sure because that's that dummy model we always use for trying out things, you know, identity input, output. And that's basically it. We can have a look at the logs once again, so they reflect what we saw. And yeah, that's it. Going back to the washboard, that's the whole application. Yeah.
Nice work, Christoph. I think it's phenomenal how you pulled all this together and really stayed at this, and I think a lot of people are going to want to use this. Steve, do you think that you're on path to get a demo together that people can cut and paste next week sometime? Maybe one of the Onyx models or ImageNet or something like that here.
That's the goal.
All right, sweet. Well. All right, I think we're all aligned here. We've got, I think the next is to take the basic example and turn it into one that really lets people see things work end to end. And then we can package this up and pull together a demo, Christoph. And I'd love to, talk about, I would love to show this off on the regular Wednesday meeting if we can. I don't know if you can ever make that. If not, maybe we can get together, have you record the example that Steve's going to help pull together in the next week, and then we can put it on YouTube and put it on Twitter and stuff like that. I think a lot of people are really. I know a lot of people are watching this because they keep asking me when it's going to be ready. So I think it's going to be exciting.
Absolutely, sure.
Yeah. All right. Well, I think we went through our 3 different topics today. Steve and Andrew and Christoph and Mingshu, it sounds like you guys got the API proposal discussed on what you think you want to pull forward and what you want to leave behind. Is that right?
Yeah, I'll make a iteration on that and send that out for feedback.
What wasn't clear to me was Bailey had talked about maybe some of the extra things that you guys had discussed, maybe pulling in but decided against. Did you guys think that pulling those together into a library was a good idea or not? I didn't quite grok that.
I think it's a good idea.
You think it's a good idea?
Especially that comment Steve had where if the library could be used both on the client side and on the server side to do the transformation, if it's flexible, that seems like best case.
Maybe that's a fast follow or something we put on the backlog because it's a nice to have, not a must have on a Moscow. Does that feel right, Andrew? Bailey, does that feel right?
It feels right to me, but I'm not the one dealing daily with the pain of doing the data transformation. I think those who daily deal with the data transformation would quickly say, oh, I must have this, right?
Got it. Okay.
Yeah, I'd have to try it out a little bit more. My main thing is that we probably want to start talking more about how some of these things fit into a component model. It's something I feel like we haven't a lot recently since it was so experimental. But I want us to start kind of fleshing that out.
Okay. So that sounds like more discussion needed on that piece, at least. I think the priorities become, just update the API, then the big example, the example tensor here, and then towards demos and stuff like that, and then the Intel example, if that's a separate step, would be third, and then we can come back and pull up on the ML tools, ML helper API functions and stuff like that. Does that feel like the right approach on this one? Yes, no?
That's me.
Perfect. Okay. All right. Well, on our side, Steve's got this one as a priority. Steve, I know you'll follow up with everybody as needed. Any other comments or things people want to bring up today on this one? All right. Silence is acceptance. I'll go ahead and stop recording and we can hang out for just a quick minute. And if not, have a great week.